Hello class, this is the continuation of chapter 1.2. We will continue this lecture with the estimations with graph, specifically bar graphs. Now a bar graph is used as a vertical or horizontal bar to represent each item. The length of the bar determines the amount. We can use bar graphs to make predictions. The bar graph on the next slide shows the life expectancy in the United States by the year of birth, so the year in which you were born. Looking at this chart, you can see that life expectancy is on your y-axis, birth year is on your x-axis. It is also delineated by males versus females, and what we can clearly see here is that females are expected to live longer in every year categorized here, from 1950 all the way to 2020. Females typically live longer than men. But we also see that from the year 1950 to the year 2020, there is an increase in the amount of time that somebody is expected to live, their life expectancy. Now, example 6 says applying estimation and inductive reasoning to the data in a bar graph. We want to estimate a male's increased life expectancy rounded to the nearest hundredth of a year for each subsequent birth year. So, if we look at our graph, and if you need to, you could go back to our other graph, but we have a small version of it right here. What we shall do is we shall take, because we are looking at a male's increased life expectancy, we will take the life expectancy of a male in 2020, which is 77.1 years. We will subtract it from the life expectancy of a male that was born in 1950. That's where we get the 77.1 minus the 65.6. We also need to have their corresponding year on the denominator. So we take 2020 and subtract 1950. We are essentially finding the slope from this point to that point. In doing so, we see that it is approximately, rounded to the nearest hundredth, 0.16. So, for each subsequent birth year, a male's life expectancy is to increase by approximately 0.16 year. So, every year, that person in the next year is expected to live 0.16 years longer than the person born in the previous year. Now, we're going to use this estimate to estimate the life expectancy of a man born in 2030. So, a man born in 2030. Well, here's what we see. Now, from the year 1950, if we look at the year 1950, from that year, a man was expected to live to 65.6 years old. However, in the year 2030, that is 70 years after the year 1950, which is where this 70 comes from, a man is going to potentially live longer. How much longer? What we do is we take our estimation from the previous problem of 0.16 years per year, and we multiply that by the additional 70 years after that initial point in 1950, which was the 65.6. So we do 0.16 times 70, which gives us 12.8 additional years that somebody is supposed to live in 2030 compared to somebody living in 1950. Okay, that tells us that in the year 2030, a male's expected life expectancy as a total is 78.4 years. So someone in the year 2030 is expected to live to be 78.4 if he is a male. So an American man born in 2030 will have a life expectancy of approximately 78.4 years. Now, we're going to look at using estimations with graphs involving line graphs. Line graphs are often used to illustrate trends over time. Some measure time, such as months or years, and frequently they appear on the horizontal axis. Amounts are generally listed on the vertical axis. Points are drawn to represent the given information. The graph is formed by connecting the points with line segments. So, this is our example using a line graph. The line graph shows the percentage of U.S. college students who smoked cigarettes from 1982 through 2020. What we can see with this line graph is that they start with the year 1982, and they have different years labeled on our horizontal axis here. They go from 1982 to 1990, from 1990 to 1998, on to 2006, 2014, 2020. We can see that that is an approximate jump of 4 years per tick. Okay, so this tick here would actually be the year 1986. This tick here would actually represent the year 1994. Because we're adding 4 years to 1990, here we added 4 years to 1982. This year would be 2002, so on and so forth. We want to find an estimate for the percentage of college students who smoked cigarettes in 2010. Now, as I said, each one of these ticks represents 4 years. So 2010 would actually be located here. What we can see is that 2010 is represented by this dot, which tells us that the percentage of people who smoked cigarettes during that time period is somewhere between 16 and 20%. So, just for another illustration, what we want to do is highlight where this 2010 is at and find the point at which it hits this line. We did that. We want to go horizontally over to our other axis and see exactly where that hits, somewhere between 16 and 20%. Then we will make an estimation on that percentage. So it says the value on the vertical axis is approximately midway between 16 and 20%. Well, what is midway between 16 and 20%? That should be approximately 18%, because 18 is halfway between 16 and 20, and that is approximately where that point hits. So in 2010, approximately 18% of college students smoked cigarettes. Now, the line graph shows the percentage of U.S. college students who smoked cigarettes from 1982 through 2020. In which 4-year period did the percentage of college students who smoked cigarettes decrease at the greatest rate? Remember that the word decrease means go down. So which one went down at the greatest rate? Now we have to look back at the graph of this in order to see this. The steepest of all decreasing line segments indicates the greatest rate of decrease. What we can see here is that the steepest line going downward, or line segment going downward, is between this period from 2002 to 2006. Okay, remember there's a 4-year jump between each of these. So between 1998 and this next tick is a 4-year jump. That's what brings this point here to 2002. And then the next jump is to 2006. So this indication of line segment here is our greatest rate of decrease. So this is the steepest of all the decreasing line segments, indicating the greatest rate of decrease for years 2002 through 2006. Now the line graph, we are still going to look at the one that shows the percentage of U.S. college students who smoked cigarettes from 1982 through 2020, working on the same example. We want to know in which year did 30% of all college students smoke cigarettes. So it says in which year did 30% of college students smoke cigarettes? Let's look at this. In order to find this, we need to go where 30% exists right here on our graph, and then we need to go over and see where it hits on our line segment. It hits here. This corresponds to the year 1998. So we need to locate 30% on the vertical axis, locate the point on the graph, and read down, which is what we did. So the year when 30% smoked cigarettes, that year was 1998. Now in example 8, we're going to model the cost of attending a public college. The bar graph shows the average cost of tuition and fees for public four-year colleges. Note that the symbol on the vertical axis shows that there is a break in values between 0 and 3,000, essentially meaning that there are no time periods in which we are representing here on the graph that the tuition was less than $3,000. Now, I'm sure sometime in the past it was, but the time periods we are looking at from 2000 to 2020, there's nothing less than 3,000. And instead of plotting all of those vertical points and having a graph that has to be much bigger, we're doing a break in the graph to show that our baseline point here is 3,000 and then above to save ourselves some space and make a graph that visually looks better. All right, so let's look at this. We go from $3,000 to $10,000 on our vertical axis for the tuition and fees. On our horizontal axis, we are looking at the ending year of the school year all the way from 2000 to 2020. A wants us to estimate the yearly increase in tuition and fees. Okay, in order to do this, what we're going to have to do is we're going to have to look at what it cost in 2000 and compare it to what it cost in 2020. So that's what we do. We take the value that it cost in 2020, $9,349 for tuition and fees. We subtract that from how much it cost in 2000, which is $3,349. We put that in our numerator. In our denominator, we put our corresponding years. For the first value of 9,349, our corresponding year is 2020. We subtract that from 2000, which corresponds to that 3,349. Okay. Essentially, we are finding the slope from this point to this point. Now, when we do this math, what we wind up seeing is after we do our subtraction, we get 6,000 on top. So it has changed $6,000 over this 20-year period, or approximately $300 per year. So the average yearly increase is about $300 from 2000 all the way to 2020. B says write a mathematical model that estimates the average cost of tuition and fees T at public four-year colleges for the school years ending X years after 2000. In order to do this, what we will do is we will take that slope that we found in part A, which is 300, we will multiply it by X. But we also must add what it initially was, our y-intercept or our initial point at that year, which is 3,349. Now we are going to use that mathematical model to project the average cost of tuition and fees for the school year ending in 2030. So here's what we do. We take our mathematical model that we found in part B, which was the T for tuition equals 3,349 plus 300x. And we know that our initial year was the year 2000. The year that we're solving for is 2030, which is a difference of 30 years. This 30 years is what we are plugging in for X. So once we plug that 30 years in for x, we are now able to solve this equation because we no longer have any variables on our right-hand side of it. We do a simple multiplication. 30 times 300 is 9,000. And we add that 3,349 to that, and we see that in the year 2030, we can expect tuition to be $12,349. So the model predicts that the average cost of tuition and fees for the school year ending in 2030 will be $12,349. This concludes the second half of Chapter 1.2 for Math 102. Hopefully you have already started on the homework from last lecture, but now you should be able to complete the entire homework set for Chapter 1.2. If you have any issues or problems or questions about this chapter and the questions and homework questions that are pertaining to it, please don't hesitate to reach out to me via email. Y'all have a good afternoon.